quantifying the impact the operation of high-capacity wells have on the flows of artesian springs and streams in the driftless area of southwest Wisconsin. Hi there, my name is Larry Larson. My wife Gloria and I own a 127-acre slice of heaven here in the heart of the driftless area in southwest Wisconsin. This is a special place for us, and our land is made up of broad uplands eroded into valleys, steep bluffs, old-growth forests, and lush valleys, and is home to literally hundreds of artesian springs, the navigable Blotts Branch stream, and about 8 acres of endangered cold water fen wetlands. We have discovered some alarming facts about how high-capacity wells impact our surface waters here in the driftless area. In 2014, the DNR approved and paid for the installation of well XN094, shown on the right-hand side of the screen, and that's a half mile away from the Blotts Branch, which is on the left-hand side. The Blotts Branch's water supply is primarily provided by hundreds of artesian springs that flow up from the bottom of the valley. Spring flows measurably drop within 15 minutes of the startup of well XN094, and when this well is run at 470 gallons per minute, within 24 hours, all artesian spring flow throughout the Blotts Stream Valley drops in half. Let me show you. First, let's go over a little orientation as to where we're located. This is a map of the driftless area, and shown on the map are the 3 primary locations where data was collected for the studies. We've done extensive testing within the Dodge Branch watershed shown here. At the bottom, outlined in blue, is the 127-acre parcel we own. Right above that, where it says Pond Spring 4, this is the location of the primary artesian spring that was tested. From this point, the white lines lead out to the 9 high-capacity wells that are all within 4.3 miles of Pond Spring 4. Spoiler alert, we've tested 8 of these wells. They all have an immediate and severe impact on artesian spring flow. This is a widespread dynamic. We're going to zero in and take a closer look at what happens when well XN094, shown here on the right, is turned on. Specifically, we're going to look at the impact this has on the surface waters shown to the left, including the artesian pond spring, the Blotts Stream, and the Dodge Branch Class II trout stream. We've utilized graphs like this extensively to plot the measured changes in spring and stream flow. So I'm going to take a couple of minutes to explain what you're seeing here. We start out with the well number that we tracked and the date that well was initially run. On the bottom here, we see the specific dates and times that the measurements above were made. On the left-hand side here, we see that these numbers represent either the gallons per minute that the pumps were running or the gallons per minute that the streams were running. On the right-hand side here, these numbers represent either the gallons per minute that the artesian spring, pond spring was flowing, or we also tracked the precipitation and the level of the shallow water table. Now, when we go over here for the tracking the high-capacity wells, it's a stacked block representation on this graph. Well, 1495 is the Golan's main facility well that runs their hatchery. It runs 24 hours a day, 7 days a week. It's always running in the background. We see here that it runs about 180 gallons per minute. For well XN094, it runs about 470 gallons a minute. Again, it's a stacked block graph, so you see in total we're running about 650 gallons per minute. Next up is the light green line, which represents the Blotts Branch stream gallon per minute flow. We can see that it's about 1,000 gallons per minute. The black line represents what the normal flow should be. And then we drop down to the olive green line, and this represents the gallon per minute flow of the Dodge Branch Class II trout stream. And here to get it on the graph, we had to divide it by 10. So when you see here that it's 1300, it really represents the fact that the Dodge branch is running at 13,000 gallons per minute. Once again, the black line represents what the normal stream flow should be. Then we go down to the Larson Pond Spring. This is the gallon per minute flow of our artesian pond spring at the dates and times that we measured it. The light blue line is year-to-date rain in inches. We can see that we've had 11 inches year-to-date and no rain at all during this time period. The final dark blue line represents the shallow water table elevation. What this represents is the number of inches it is from the top of the shallow water table to the bottom of an old stagecoach well that we are monitoring. We've put reference letters on the graph to use as a guide as to when specific events occur on the timeline. Let's take a look at A on 519 to see what the pond springs look like before well XN094 was started up. It's May 19th, 2016. We're at the exit of the Larson Pond Spring. We just took a measurement. I mean, it's measured at 30 gallons per minute, but we're losing water everywhere. Again, that's at a minimum. We know it's running at least 30, probably more than that. Now let's take a look at B and see when well XN094 started up. It's May 20th, 2016 again. Just thought I'd give you, there's not anything coming, again, deer walking through the picture. There's not anything coming through the transfer tubes, but where all the water's coming from is from the side outlet, which I'm assuming because of the power of it, this is because the well XN094 is currently running and pumping water into these ponds. Let's look at C and check out what the spring was doing 6 hours after the startup of the well. It's May 20th, 2016. We're at the exit of Larson Pond Springs. Golan just had started up his ponds this morning, probably around 8 o'clock we're thinking. It's about 4 o'clock in the afternoon now, so it's been running for about 6 hours. We took a test of the springs yesterday and they were running in excess of 30 gallons per minute. We took a test this morning at 11 after we noticed they were running and we had dropped down to 26 gallons per minute. And now, with where it sits at the moment, we're running at 21.7 gallons a minute. So, let's take a look at E next and see how much spring flow dropped the day after well XN094 started pumping. It's May 21st, 2016. This is the Larson Spring. Yesterday at 8 a.m. this was running at 30 gallons per minute. It is now running at 13 gallons per minute. Let's jump back to D and see the drop in pumping volume. In the video, as I'm panning up the ponds, I note that one of the outlets was not running, but I was wrong. If you look close, you'll see it is running, but at a reduced volume. It's May 21st. 2016, it's 11:20. My son pointed out about 10 o'clock that he didn't see the pumps running. Anyway, thought we'd zoom in here, see there's nothing in the transfer tube and also that there's nothing coming out of the pump tube. However, you go up to number 6 and there you see that the pump is still running there and the transfer tube is still empty. Let's now take a look at F and see when well XN094 was shut off. It's May 22nd, 2016, 4 o'clock in the afternoon. Golan appears to have quit pumping for the day. See, there's the bottom. It appeared to, that's where it was running. You can see the tube, and nothing running through that, nothing through the transfer tube. Oops, get up to the next one. Nothing running there. Now let's take a look at G to see how much spring flows recovered from the 13 gallon per minute flow we measured 24 hours before when well XN094 was first shut off. It's May 23rd, 2016 at about 3 p.m. We're at the Larson Pond Spring. We just did a test measurement here. The spring is up to about 21 gallons per minute coming through that hole. Again, going. Stopped pumping yesterday about 4 p.m. Our springs, this spring specifically, has been growing in strength ever since. Let's review what we've learned from what we just saw. On the right side of this map, you can see the location of well XN094. In the middle of the map, 6/10 mile away, you can see the artesian pond spring whose flow was measured. Upon the startup of well XN094, spring flow started to drop like a rock. The springs were flowing in excess of 30 gallons per minute prior to startup and had dropped down to 15.5 gallons per minute within 24 hours, a 50% loss in flow. Then the pumping volume was reduced down from 470 gallons a minute. Even at this reduced volume, spring flow continued to drop, albeit at a slower rate of descent. When pumping was halted on 5/22 at 3 p.m., spring flow immediately started to recover, and within 24 hours had risen from 12.8 gallons per minute to 21 gallons per minute, almost doubled its flow. The other thing to note is the length of time it took for the watershed to recover. Well XN094 was run for only 55 hours. After being shut down for 55 hours, spring flow had recovered 85% of its volume. So in this instance, it took longer for the watershed to recover than the amount of time well XN094 ran. Let's take a look at what happened to stream flow during this run. We'll start by looking at the impact this pumping had on the flow of the Blotts Branch stream. The Blotts Stream Valley is heavily populated with artesian springs. They emanate from three major areas. The Green Hex Spring area up on the top, the area around the artesian pond spring that we measured in the middle, and on the left-hand side you can see the outflow from the cold water fen wetlands. The Green Hex Springs area contains hundreds of artesian springs flowing at a gallon per minute or less. As seen on the map, they do have several larger artesian springs. The largest is located by the number 1, their pond spring, which, like ours, runs about 50 gallons per minute. In the area around our artesian pond spring, shown above, there are dozens of larger springs that flow in excess of a gallon per minute. The Blotts Stream Test Station, shown on the left, is about 50 feet upstream from the pond spring wear test station, so we could measure the change in upstream volume. The outflow from the endangered cold water fen wetlands is once again supplied by hundreds of artesian springs that sustain these wetlands. We're going to walk you through the calculation documenting stream flow change. What you're looking at is our field notes on the calculation of the Blotts Branch stream flow. From this document, we retrieve 3 vital measurements. The red number 1 shows how we calculated the 1,081 gallon per minute stream flow. Number 2 shows how we calculated that each inch of water represents a flow of 230 gallons per minute. Number 3 shows that the stream gauge level reading was at 13.2. Here's a photo documenting that level. This is a look at what happened to the Blotts stream flow during well XN094's run on 5/20/2016. To maintain consistency in gauge level readings, we would take 4 to 6 photos of the gauge and use the picture with the lowest reading. Next, we'll look at how we determined exactly where on the gauge the water is breaking. So if we zoom in here a little bit, what we can see, what you're looking at here is the beginnings of refraction. Again, this is a straight line, so when you see it flare out like this, you can tell that you're looking through water. This is where refraction begins, and that's where our mark is as far as what the level of the stream is. So this shows us that the gauge reading is 12.92 and that it's running 1,017 gallons per minute. And when we go back here, that was on 520. On 522, we see that, yeah, it's dropped. Again, the straight line, refraction begins. That's where the measurement is taken. The gauge reading is at 12.64, and that represents a 952 gallon per minute stream flow. So, anyway, so as you can see, within 2 days, the flow of the Blotz stream dropped from 1,017 gallons per minute down to 952 gallons per minute. And this represents a stream flow loss of 61 gallons per minute, or a 6% drop. Now let's take a look at what happened to the Dodge Branch Class 2 trout stream during well XN094's 5/20/2016 run. Once again, we start out with our field notes showing how we measured the Dodge Branch Class 2 trout stream on May 3rd. Once again, we're picking up 3 vital pieces of information from this document. The red number 1 shows how we calculated that the Dodge Branch Class 2 trout stream was running at 14,546 gallons per minute. Number 2 shows how we calculated that each tenth of a foot of water represents a flow of 1,809 gallons per minute. And number 3, once again, we show that the stream gauge reading was at 7 at this point. This is a look at what happened to the Dodge Branch Class 2 trout stream during well XN094's run on 5/20/2016. As you can see here, before the run, we took a gauge reading, and it shows at 5.976, which represents 12,694 gallon per minute stream flow. 24 hours after the pump shut down, we had a gauge reading of 5.731 with 12,250 gallons per minute stream flow. Let's review what we've learned so far. So, when they started up well XN094, the artesian pond spring went from 30.41 gallons per minute down to 12.8 within about 30 hours, where we lost 17.6 gallons, or 58% of spring flow dropped during this run. Now let's go take a look at what happened to the Blotz stream. At the beginning, here, it was running 1,017 gallons per minute. At the end of the run, when well XN094 shut off, it had dropped down to 952 gallons per minute, for a loss of 65 gallons per minute. Now, a normal drop, based on the flow of the East Branch, Pacatonica, and Blanchard field, should have dropped 4. So we only really have a loss of 61 gallons per minute. But that represents a 6% loss. And then finally, let's take a look at the Dodge Branch Class 2 trout stream right here. Okay, so before they started up, we had a flow of 12,694 right here. 24 hours after the well shut off, it had dropped down to 12,250 gallons per minute. Might have been better if I would have taken it earlier, but I didn't get there. Anyway, so to this point, we had a loss of 444, or a drop of 444 gallons per minute. Now, again, during this time period, we should have seen, the black line represents this, it should have seen a drop, and that drop would have mounted at this point to 169 gallons a minute. So we did in fact have a loss due to the running of well XN094 of 275 gallons a minute, or 2.2%. Now, let's take a moment here to see whether these measurements appear reasonable. So for sure, we got this 58% loss in the artesian pond spring. Now, the Blotz stream, we know, is heavily populated by artesian springs, so this should have a relatively big impact, and we see that it has, in fact, dropped 6%. On the other hand, the Dodge Branch Class 2 trout stream is fed by a lot of different areas and isn't as dependent on artesian spring flow, and so that we see that only dropped 2.2%. So, in fact, the numbers not only are accurate, but they make sense. After this 5/20/2016 test, we were sort of anxious to see what was going to happen next. We didn't have to wait long. On 6/2/2016, we see here that, well, XN09 started up again. We're going to pass at the moment on reviewing detailed documentation and just discuss what we see here. So on this run, on 6/2, we not only started up well XN094, but we also started up well RT048, which is 9/10 a mile away from us. Again, in total, the three wells combined, including 1495, which always runs in the background, is pumping at 800 gallons per minute. The effect, we see that in the red line that represents spring flow, that it drops from 26 gallons a minute down to 8 gallons a minute within basically 24 hours of the startup of these wells. And then we also see that once they shut off the wells, the spring volume begins to recover. And then we go from 8 gallons a minute up to about 18. So initially we lose 70% of the volume, and within 30 hours we recover 80% of that. So once again we see that the recovery is taking longer than the well originally ran. Now let's jump up and take a look at the blot stream. The bright green line represents the blot stream flow. As we can see, at the beginning of the event, it was running 1100 gallons per minute, and by the end of the event it had dropped down 100 gallons to be running only at 1000 gallons per minute. The other thing to note on here is at least this time the Blotts Branch stream did not recover. Looking at the top olive green line that represents the Dodge Branch Class 2 trout stream, we see from this graph that I didn't record any flow for the Dodge Branch during this run. 2 years later, on 6/1/2018, we went back to check on well XN094 to see whether anything had changed, and found that it did not. Once again, when we see that well XN094 started up, we see spring volume drop from 36 gallons a minute down to 10 gallons a minute within a span of 30 hours. Again, a 70% loss in spring volume due to this pumping. And also, once again, you see that once the pumps turn off, the spring volume recovers. And again, it appears that it's taking longer for the watershed to recover than the amount of time that the well originally ran. I think it's appropriate to point out here that the foundation of scientific fact is repeatability. What you're seeing and hearing about today are the facts of how high-capacity wells are impacting the surface waters in the driftless area. There's no theory involved here. The reports are simply about what is actually happening. Let's step back and look at the big picture. What you're seeing here is a timeline graph detailing what transpired in the Dodge Branch watershed from April through the middle of August in 2016. There's a lot of information here, but we're going to look at how artesian spring flow, represented by this red line, and the depth of the shallow water table, represented by this dark blue line, is impacted by precipitation, represented by this light blue line, and the operation of these 5 high-capacity wells, represented by these bars. For orientation purposes, here again is the test area of the Dodge Branch watershed. The Dodge Branch Class 2 trout stream is represented by this purple line, whose headwaters is in the city of Dodgeville. As it crosses Highway 151, it's running at 1,400 gallons per minute. It comes down after about 3 miles coming down through the valley. It exits the valley at County Y, and at this point it's running 14,000 gallons per minute. Here are the 5 high-capacity wells that we graphed, specifically looking at well XN094, the closest one that we've gathered the most data on. This whole area throughout here is heavily populated by artesian springs. And up here, on the left, we have the 4 high-capacity wells that are run from the city of Dodgeville. This is a 2-scale geological map of the Dodge Branch watershed. There's a lot of information here, but I wanted to highlight the location of these 5 high-capacity wells that we kept track of, including well XN094, and their close proximity to the measured pond spring, the blot stream, and the shallow water table. Up here on the left, we have the 4 high-capacity wells run by the city of Dodgeville. What we'll eventually see is that these wells also cause a drop in stream and spring flow. We'll find that the damage they cause is nowhere near the magnitude of losses generated by these 5 high-capacity wells drilled right in the valleys where all this artesian activity occurs. There's a couple of reasons for this. First of all, there's proximity. The Dodgeville wells are between 3 and 4 miles away from the springs and the streams. Secondly, and most importantly, is how they're run. These 4 wells in total don't run more than 8 hours a day, which leaves 16 hours per day that the watershed can recover. As we've seen, the watershed recovers quickly once the pumps are shut off. Thus, by the end of the day, everything's back to normal. This is not the way the Golans run their wells. We're back to our timeline graph. A couple of things to note. These were all blind tests. Now, we had no idea when these pumps were going to start up or shut down. During this time period, we had our hands full just gathering the measured test data from the 16 different test locations throughout the Dodge Branch watershed, and also keeping track of when these 5 high-capacity wells were turning on and shutting off. We were able to determine the direct correlation between the operating of these high-capacity wells and the losses they generated once we graphed all the data we had collected and broke the analysis down into these 9 separate quantifiable events. Now, when I say quantifiable events, it means that we knew what was happening with stream and spring flow at the beginning of the event. At the end of the event, we tracked what happened during the event so that we could then put ourselves in a position to actually calculate the losses that these high-capacity wells created. For our overview of the big picture, we're going to pick up where we left off. As you'll see here, we began on 5/20/2016. This is the graph that we had shown in detail where we showed all the videos of what was transpiring and when. We go through event 4. Event 4 basically was just a rain event. We got 5 inches of rain. Starting in event 5, we see that once again the Golans started their pumping. We see this huge drop, and then the recovery once the pumps are shut off. Again, we did see that. We already have seen that graph in detail. We go to event 6. We now introduced another well, RTO48, the main facility well. In addition to that, we've got about 5 inches of rain. What we note here again is the immediate drop in spring volume once the pumps are shut off, and the recovery once it stops. When we get into event 7, we added another well WX275, that's 2.1 miles away. We see for rainfall, we had a little sustaining rainfall during this period, but nothing of any consequence. With the addition of the more wells running, we see a constant drop in artesian spring flow. We also see now that the shallow water table is starting to dive. We go into event 8. There's a little rain event here. You can see that did have a little impact on spring flow. Again, after a couple of days after it stopped raining, spring flow went down and started dropping again like a rock. Also, we see that the shallow water table here is still dropping, and back on 7/16/2006, at that point, the old stagecoach well that we were monitoring was completely dry. So it's probably good to point out that from 5/20 to 7/20 here, we had 15.5 inches of rain. Normally during that time period we would have gotten 10 inches of rain. So we had a 50% increase in precipitation during the time period. And let's take a look at how that increased precipitation affected the flow of our pond spring. It's July 20th, 2016. We're at the Larson Pond Springs. Golan has had all his pumps now running for 35 hours. You can see my springs are completely gone at this point. Thought it might actually take 48. Anyway, all the artesian activity around here has halted. There's absolutely no flow. So, as you can see, precipitation has nothing to do with the drying of the artesian springs. It all has to do with running these high capacity wells. Now, we're going to take a little closer look at event number 9, just because it's a nice study in and by itself. We see here that we got 10 inches of rain within a week. And what does that 10 inches do? Well, the Dodge Branch Class 2 trout stream went right off the charts outside of its banks. The blot stream went again off the charts outside of its banks. The shallow water table, well, that filled right up. And as far as the artesian pond spring, well, we got up to 8 gallons per minute of runoff right after the rain. A couple of days later, it went back down to 0. And it stayed there, except for runoff, for the next 2 months. This is a summary for 2015 and 2016 showing the total gallons pumped from the Golan's 5 high-capacity wells by month. And that's compared to the measured range of artesian spring flow during that month. So, in 2015, we see here in July, when we first noticed that this was going on, our measured spring flow rate was between 0 and 10. I mean, it's been 0 for a couple of weeks, and when it did run, it ran at only 10 gallons per minute. In August, when they ramped up their pumping, and we're averaging now 653 gallons per minute, all artesian spring flow within the watershed stopped. Again, in September, they were averaging 636 gallons, also no artesian spring flow during that month. In October, when they were averaging 665 gallons per minute, once again, there was no artesian spring flow. In November, they backed off on their pumping and were pumping at only a 246 gallon average. At that point, spring flow returned about 13 to 15 gallons per minute. And when in December, when the only well that was running was well 1495, the well that supports their fish hatchery at their main facility, that was running 171 gallons per minute, and the spring was flowing at 27 gallons per minute. In 2016, during the detailed test period, in July they averaged 452 gallons per minute, and as we previously noted, it dried up, and when it did run, it was running at only 15 gallons per minute. In August, they ramped up their production and averaged 730 gallons per minute, and again, there was no artesian spring flow throughout the whole watershed. In September, when they averaged 587 gallons per minute, once again, there was no spring flow. And then they started backing off in October, averaged only 442. We averaged between 15 and 18 gallons per minute spring flow during that month. In November, when we backed off a little more and averaged only 282 gallons a minute. Our spring flow was between 18 and 31 gallons per minute. And then once again in December, when the only well that was running was 1495, running at 183 gallons per minute, our spring was flowing at 31 gallons per minute. So, when they suppress all the spring flow in the watershed, they don't just do it for a day or two, they do it for months on end. And it's just not any month. It's what's usually the hottest, driest part of the year. We've mentioned well 1495 several times, and turns out this is the elephant in the room. We don't yet know how much damage well 1495 has already inflicted. The one thing we learned from studying this graph is that anytime you turn on or off one of these wells, that causes a severe change in spring flow. Let's take a look back at event 1 and 2 to see if this little tidbit of information could help solve the mystery of how much damage well 1495 is causing. This is a close-up look at the first 3 events on our timeline. You see here on the right our May 20th tracking of well XN094 that we've examined in detail, and also it highlights our little tidbit of information that when you turn on one of these wells, spring flow drops like a rock, and when you turn it off, it rockets back up. Let's see if we can use that tidbit of information to discern what's going on over here. So we see that spring flow sort of rocketed up here from the end of the month to 414. Now, if this can be believed, this would indicate that somebody shut off a high-capacity well. And the most likely suspect is this well 1495 run by the Golans. Well, 1495 usually runs at 180 gallons per minute, and even though we have no way to independently verify when these pumps are shut on or shut off, we did in fact properly account for all the water that Golans reported pumping during this time period. What we did is let the springs determine when the wells were shut off and when they were running. It appears that our random data collection stumbled upon a time when well 1495 was turned off. That's a bit of luck. We get a rare glimpse of what spring and stream flow would be in the Dodge Branch watershed if we didn't run any high-capacity wells. We're going to get a twofer here. We're going to extract two important facts from one calculation. We're going to take these three individual quantifiable events and combine them into one big event. And what that's going to show us is what the impact of starting up and continuously running well 1495 has on the surface water flows, in addition to finding out what a well sunk in the valley, run at 500 gallons per minute, is doing to the watershed flows also. So let's go over what we see is happening. Again, the dark blue line here is the level of the shallow water table. Our first test was here on 421, and we can see during this time period there was just a steady decline in the height of the shallow water table. As far as artesian spring flow, again on 414 we were up here at 46 gallons a minute. On 522, after we were running for 500 gallons a minute for 2 days, we were down to 13, or a 72% loss in artesian spring flow. Now let's take a look at what happened to the Blotch Branch stream. This is the light green line here. Again, the black line represents what the Blotch stream flow should have been based on what was going on at the East Branch Pecatonica. Again, we should have seen a decrease, nowhere near what we actually experienced. In event 2, we had a little rainfall, and we would have seen very little drop in the Blotch Branch stream, where in fact it continued dropping. And then of course, once you started up well XN094, it continued to drop. Now let's take a quick look at what those gauges look like. So on 414, when nothing was running, we see that the gauge reading was at 14.3, or it was running 1,334 gallons per minute. Over here at the end of the run, we have a gauge reading of 12.64, which represents a flow of 952 gallons a minute. So we dropped 382 gallons per minute. Now let's take that information and bring it over to our spreadsheet here. This is a summary of surface water losses caused by the starting up of wells 1495 and XN094. So on the Blotch stream, you can see, yeah, that was the gauge on 414. It read 14.3, and that represents that flow. And then at the end of the run, it would drop down to 12.64, which represented a flow of 952 gallons a minute. So the flow dropped 382 gallons a minute. And again, based on what was going on at the East Branch Pecatonica in Blanchardville, we should have seen a drop of 141 gallons. So the loss due to the running of a well at 500 gallons per minute was 241 gallons per minute, or we experienced an 18% drop in the Blotch stream. Now, this is upstream from the artesian spring, and what happened with the artesian spring is we went from 46 gallons a minute down to 13. Again, during a season, we should see no huge fluctuations in the flow of artesian springs, so that the whole thing was a loss. Again, we lost 72%, so that the total loss after my springs was just 241 plus 33. So we dropped 274 gallons per minute while the Golans were running at 500 gallons per minute. So let's take a look at what happened to the Dodge Branch Class 2 trout stream during this period. Now again, in event 1, we weren't set up, so we have no idea what transpired during that event. However, we do have a good starting point for event 2 and a good ending point at the end of event 3. Again, you work with the facts that you have available to you. So the black line once again represents what normal stream flow should be, and we see with this little rain event we had a pop-up of volume for a bit, and then it dove down a lot more than what we should have been able to see. And then in event 3, when we started up well XN094, we can see that this dove down, and once they shut it off, it returned back to normal. So the other thing to note is what we calculated as a normal stream flow appears to be spot on. So let's take a look at how those changes look like on our gauge readings. Again, here's the gauge for the Dodge branch at County Y. Back on 5.3 when we first did the test, the gauge reading was at 7, which represents a flow of 14,546 gallons per minute. Back on 5.23, when after they shut off the wells, we find that our gauge reading was at 5.731, representing a flow of 12,250 gallons per minute. So we lost around 2,300 gallons per minute during this time period. Now let's go ahead and post those to our spreadsheet here. So we got the Dodge branch class 2 trout stream. The gauge reading, again like we saw, it was 7. It represented 14,546 gallons per minute. It had dropped down to 5.73 at the end. So we had to drop a flow of 2,296 gallons per minute. Again, based on what was happening over at the East Branch Pecatonic in Blanchardville, we should have seen a drop of 616, which means that our loss that was generated by running these high capacity wells at 500 gallons per minute means that we lost 1,680 gallons per minute. What this works out to is that on a daily basis, the operation of a high capacity well in the valley is going to withdraw 2,400,000 gallons of water from the Dodge Branch Class 2 trout stream. The Dodge Branch Class 2 trout stream is on the fully impaired waters list, and we have now identified one of the major contributing factors to the demise of the health of our trout stream. We've pretty much quantified the impact any of these 5 high capacity wells will have on the watershed when run at 500 gallons per minute. The next question is, well, if you can see all these 5, can you see high capacity wells farther out? Well, to test out this, we went over here to Dodgeville. On March 11th, 2019, we tested these 2 wells, Lindsay Street and Union. The one nice thing about the city wells is that we have access to them, so we can tell exactly when they're turning on and turning off. For these 2 wells specifically, the city of Dodgeville has gone to the trouble of actually installing meter readings on the outside so that we could track when they were operating, can figure out consumption rates and determine exactly when these wells turned on or turned off. In addition to that, we just asked the city of Dodgeville what they ran for the day, and they give us that, so we can be a lot more exacting in the timing and the quantity that they're running. Certainly a lot more than what we were able to do with the Golans. Now, we're going to take a look at this graph. One of the things I wanted you to note is that the pond spring flow, rather than going from 0 to 50, now goes from 35 up to 47. Again, we did that to highlight the changes in spring flow. So when we see here that well 1495, again, is continuously running in the background. And we start up here at the day before at 4 p.m. We were running about 46 gallons a minute. At around 10:15, we started up the Lindsay Street high capacity well. At 10:27, we took our first test, and it was running at about 44 gallons per minute. The Union Street well started up at 10:42. We see how spring flow was dropping at that point. 10:57, we were down here at a little over 40 gallons a minute. With them both running, we continued to see spring flow drop until it bottomed out here at 38 gallons a minute. Then, so we got a loss from 44 down to 38 within an hour of the startup of this well from Union Street. Then, of course, the Lindsay Street high capacity well turned off, and spring volume started popping right back up. Now, what happened to spring volume between here and here, I don't really know. It was cold, so I took a nap. When I got up, and after I checked the meter readings for these wells, we went back at 4:40 and started testing and found out it was coming in at 41.5 gallons a minute. Once again at 5 o'clock, basically the same rate. This well from Union Street stopped at 5:01 p.m. What we see is that the spring volume immediately starts recovering, and by 6 p.m. it's pretty much back to normal. As so is same thing happened at midnight. Now we did track the flow of the Blotts Branch stream during this time period. We didn't actually put it on here because the impact, although you could see a small impact from the day before, again it returned to normal, and it appears that this had very little impact on the flow of the streams in the area. On 4/25/2019, we were able to isolate this Land's End well number 8, that's 4.3 miles away from the pond spring, and do a test on that. This is the test that we took on April 25th of Dodgeville's high capacity well at Land's End, that's 4.3 miles away. We're going to just briefly touch on this because it's pretty easy to interpret. We've got the well when it starts up, it drops down 4 gallons per minute, and when it shuts off, it recovers back to normal within a very short period of time. I mean, we do note that once it started up, we didn't see the effects immediately, and that's because it's pretty much 4.3 miles away. Also during this time period, we didn't have any measurable change in stream flow. So what we find is that at 4.3 miles away, we're at the outer edge of where the effects of operating a high capacity well can even be seen. We've pretty much figured out how high capacity wells are affecting surface water flows here in the Dodge Branch watershed. The next question is the dynamic at play here in Dodgeville the same throughout the whole driftless area? Try to answer that question, we went 30 miles west to the town of Lancaster to test the Rogers River watershed. This is the Rogers River's watershed, and the Rogers River right here. Scott Hartline Spring is a spring that we had tested. You can see the 2 Fenimore wells and 3 Lancaster wells that we tracked. Again, this was a target test. We didn't try to track every high capacity well in the area. We tried to just track these 5 and see whether in fact we could find any correlation at all between the running of those wells and the flow of the springs. The geological map of the Rogers River watershed is very similar to the Dodge Branch watershed. Again, we can see it's all the same aquifers. We're, again, the driftless area. We have a contiguous aquifers underneath us. Once again, what you're seeing is that when erosion is eaten into the St. Peter, Prairie du Chien, Jordan Sandstone confined aquifer, you have a heavy prevalence of artesian springs. Here's the result of the test that we conducted on 5/13, and let's see if we can find any correlation between the running of the pumps and the change in spring flow. These 2 wells are run in tandem during the off hours for Lancaster. They stopped at 6:45 a.m. Our first reading was at 6:55 a.m. at 210 gallons per minute. Within an hour and a half, it had risen to 240 gallons per minute and then dropped back down. What we found, not only in this test, but in the preliminary testing that we did to get ready for this, is that during the day when this pump is run, we average about 220 gallons per minute. When the pump is turned off, we average 240. Again, we see that high capacity wells do have an impact over here, although, again, because of the location of where the wells are, it's not a significant one. Artesian spring areas sensitive to the operation of high-capacity wells are pretty easy to identify. These artesian springs emanate from the confined St. Peter, Prairie du Chien, Jordan aquifer at elevations less than 1,000 feet. This elevation map shows that the brown and yellow areas are below 1,000 feet, and it is here in the valleys that you are likely to find numerous artesian springs. The DNR simply needs to accept the scientific facts and put in place controls that will ensure that we don't keep on making the same mistakes by placing high-capacity wells in sensitive areas that drain our surface waters. I'd like to thank you for your time and attention, and I hope we have enlightened you a bit as to the dangers and damage that high-capacity wells can cause here in the driftless area.